dreams, they feel real while we're in them, right? It's only when we wake up that we realize something was actually strange. Let me ask you a question. You never really remember the beginning of a dream, do you? You always wind up right in the middle of what's going on.
I guess, yeah.
So how did we end up here?
Well, we just came from the,
Think about it, Ariadne. How did you get here? Where are you right now?
We're dreaming?
You're actually in the middle of the workshop right now, sleeping. This is your first lesson in shared dreaming. Stay calm.
If you thought you were tuning into just another Flat Earth Friday, you're wrong. Welcome to the brand new virtual reality podcast. How are you doing this evening, brother?
I'm good. I'm excited to be here tonight, and thank you everyone for tuning in. Hope you're all having a great Friday.
Yeah, so we're used to doing Flat Earth content on Fridays, and we like to stream on Fridays, but Flat Earth is just about the shape of the floor. So we've been beyond Flat Earth for the last over 7 years, and we're really just going to strike out and forge a new territory in virtual reality. It's uncharted territory. A lot of people are afraid to go into this topic, but we feel like we know this topic well, and we can actually even prove to everybody the Earth's a VR. What do you say to that?
Yeah, so many places, so many people, Nick Bostrom, Elon Musk, Neil deGrasse Tyson. You get all these scientists and physicists and astrophysicists, and they all tell you that, you can deduce through different calculations and, because of the fine tuning, Leonard Susskind will tell you of reality and all this other mumbo jumbo nonsense, but no one will actually point you to observable evidence that we live in a supernatural non-physical reality. You'll have channels that are out here talking about how the Earth is flat, but yet everything is physical, observable, demonstrable reality. Then you'll get the other side of the crew saying stuff like, oh yeah, the sun is definitely physical. The heliocentrists, like everything has to be rocks, atoms, and solid objects for things to be upon. But really, when we drill down and we start to investigate things here, we find out that it's actually not physical, and that everything that we see is made from what's not seen, and that is physical is actually not physical.
And that it's information based, and that it's mathematically based, and a whole bunch of other things like that. So we've got quite the array of different proofs of Earth being a virtual reality that they're just all arrows in the quiver, and we bring them out and share them with y'all so that you can see for sure that Earth's a virtual reality. And then if you want to be able to show somebody else, you have ways to show it to them too. So one of the things that we're going to be talking about tonight is something new that we've never really introduced. This as a virtual reality proof. It's something that just sort of over the course of the last week just sort of struck me that the formulas that we use in what's quote unquote physics, right? The formulas that we use for calculating the speeds of things, the sizes of things, all these different things, the formulas themselves, we're going to be showing everybody how the use of the square root function is actually going to be proof that you're in a virtual reality, because you're going to see how complicated it is to actually come up with square roots, and that the only way you can do it is computationally with algorithms and with charts. And so once again, this is not the type of thing that an atom is going to be able to calculate. So they say an atom is made up of particles that are too small to be seen with angular resolution. And then they say that there's smaller particles within that orbiting around each other And then we're somehow to believe that these atoms are able to do mathematical equations because all the things that they affect behave according to mathematical calculations. Right?
Yeah. And it's crazy how they say on the tiny scale, it's actually mirroring the large scale. So we have supposed solar systems where everything is spinning around suns and nucleuses and protons and electrons and different moons and stuff like that. And what they've done is they've taken what we observe in the sky and turned it into a worship. They've created grand imaginations based upon things that men's hearts desire. They want to be able to, quote unquote, discover the universe. They want to travel to other, quote unquote, planets of terrestrial rock. And they think that they'll be able to colonize. You know, it's really out in the forefront right now. Elon Musk is saying that basically the only way mankind can survive is if we actually inhabitate 2 planets, he's saying. So that way, if an asteroid comes and takes out one, there's a better chance of us surviving on the other. And then people are saying, well, how are you going to support the life on the other one if they're supposedly... So when we look out into the universe, supposedly in the sky, there's no evidence of anything but twinkling lights. There's no life. There's no water. There's nothing that we can zoom in on and see, oh yeah, there's an alien kangaroo hopping around on that sphere rock.
Well, and another thing you got to remember is that once you get up to 30,000 feet, those twinkling lights are gone. You would think that you'd be able to see them better, but no, all of a sudden you're above them.
Yeah. And so what we really have is the understanding that we have little to almost no complete understanding of who we are and where we are if we go down the path of modern day science. And what we need to understand is that this existence is actually a supernaturally based life where we're evolving eternally through reincarnation. And the job here is to evolve and work on ourselves. It's not to have fantastical ideas of, you know, traveling to these other solar systems where supposed planets orbit around other suns, when in actuality, we should be taking care of each other in this realm and just actually pointing cameras and looking at things. And so we're going to be showing you tonight how, you know, trees can respond to sound, how water reverberates, and how the effects like the morphic resonance, or how once one dog learned how to ride a skateboard, all the other dogs around the realm are now riding the skateboards. There are so many things that we can point you to that just opens the mind and allows you on the other side of the screen to investigate the type of reality that you're in. Jason and I, we test. This is how we met each other. We're both into investigating things. We look for patterns and we try to analyze them, and then we try to see why or what could these things be doing. And one of my first was clouds behind the sun, right? And clouds behind the moon, and clouds behind the rainbow. And you look at that and you go, how could that be possible? Let's see if we zoom in or zoom out. Is it a focal length issue? Can we so sometimes you can have a power line that could look like it's going behind the sun. So when you adjust your focal length or your zoom, all of a sudden you pull that line back out in front. But what you can't do is when you have certain types of clouds that are both in front of and behind the sun, you can't pull the clouds back out in front. And then you start to investigate, well, what's happening at sunrise and sunset? And you start to see that, yes, the sun is literally rising up from your vantage point, from your perspective, out of the ground, circling around you, setting back into the ground, going underneath your feet, and then rising again. And it does that for each one of us. And depending on our latitude and longitude, we have a different arc and path to the sun. These are the obvious things that the virtual reality shows us. We're going to be getting into so many more, like the shadows. So, you know, there's been a lot of talk about geoengineering and, you know, blocking out the sun and chemtrails and if it's real, and, you know, how the actual byproduct of the turboprop planes that they use now, depending on the moisture and elevation of the planes, is a cloud. That's what these engines do. They compress oxygen, they turn it into boost, and what comes out of the back of the engine is a cloud. And it spreads out and stays up in the sky until it finally does dissipate. And so what we need to do is we can use these clouds and these chemtrails or plane contrails, and we can see what happens with the interaction of the shadow and the sun. And when we start looking around at all that, we're going to start to see that this is a you and me and everyone else centric virtual reality. And I'm just excited to show people the evidence and the proofs. Now, the math I find fascinating. I know a lot of people, that wasn't their favorite part of school, arithmetic and multiplication and trigonometry. And maybe you don't work in the construction industry and you're not constantly using math. But for me, I do find it fascinating, and understanding square roots. So when you try to find the square root of 10, you'd think, oh yeah, it's easy, right? No, it's very, very difficult. When you talk about odds and even numbers and then codes and how this reality is written on a code, you've got these groups of people that take DMT, and when they stare into a pink laser, they can actually see code. They can literally see code in the laser beam. There's so many fascinating things about this virtual reality that we're just scratching the surface. And lastly, Jason, before I give it back to you, it's 2025. You've got channels out here that go around saying that the Earth is a sphere because of a single observation. Well, if the Earth was a sphere, it's 2025. We still don't have a live feed of the Earth spinning in real time. Not one single proof that anything's ever gone high enough to actually show us that we lived on a sphere Earth. We don't have one piece of evidence that the Earth is actually hurtling or moving or flying through this endless, infinite universe. But what we do have is a fixed stationary plane of reference, and we can measure everything else in the sky rotating around each one of us.
Yeah, don't worry when we get into the math, everybody. We're not going to be learning algebra and all that kind of stuff. We're going to be looking at it from a conceptual basis. We're going to be using Chat GPT to keep things simple and very comprehensible. No tough math today, but it is math nonetheless. This whole thing with Earth being a virtual reality, for you and I, it's like no big deal. We think it's great news. For so many people, it's like, I don't know what the reluctance is to actually accepting the Earth's a virtual reality. I feel like the news is much better when you understand Earth's a virtual reality, and that you're not atomic stardust, that as soon as you die, that you're going to dematerialize and become nothingness and have no conscious memories, no afterlife, no none of that. So, you know, it's shocking to me that so many people want to hold on to that type of reality when the evidence is out there where a person can see that, yeah, once you're in a virtual world, then all of a sudden you can understand reincarnation. You can understand being reborn again. So that's what you expect in virtual worlds, that if you set a lifespan that you're reborn. So we also know from the Bible that these bodies weren't meant to die, that originally the bodies Adam and Eve had, they weren't going to die, that death was a result of sin. So we were given these types of mortal bodies that you have to feed it, you have to water it, you have to do all these things to take care of it, and you have to learn to become a good steward of your body in order to maintain health and a longer life. So the idea of Earth being a virtual reality, I'm excited to get back to that immortal body. That's what the creator of this world has said we're going back to paradise Earth, the way it was originally intended. And all the wickedness, the last 6,000 years has been a test to see how mankind would do once they fell out of believing that there was a creator. And that didn't really happen until the whole space propaganda thing took place in like the 1850s. So we're at a very unique time in the world where we have the technology to be able to see things like clouds behind the sun. We're be able to zoom in on things and see what's taking place with more angular resolution than our eyes have. So the technology that we have to be able to do the square roots, to be able to share these types of graphics, to be able to go through the things that we're going through, they're actually all proof of Earth being a virtual reality. So I don't know, there was we heard today that the TFE thing is the documentary is going to be soon, that Will Doofus is going to be sunsetting soon. He's going off into the sunset, and yeah, what's going to be left? I mean, it's going to just be us, because we know the Earth's plane, and we didn't fall for the final false dichotomy psyop, and we're just going to keep sharing with everybody that Earth's a virtual reality, right?
Yeah, and showing you the evidence and asking you to go out and investigate your reality for yourself.
Yeah, so if you want, we can get into
Get into your stuff, yeah.
The natural laws stuff a little bit. And what we've got here is a question to ChatGPT. How many natural laws are there that have a square root as part of their formulas? All right. I just wanted to sort of hit it with a left hook where it didn't really know what was going on. And it said there's several natural laws in physics that include a square root in their mathematical expression. So it says the term natural law is broad and can apply to many empirically observed principles. And many such laws or derived equations can involve square roots. Square roots often emerge from solving quadratic relationships, variational principles, or in a process involving energy, distance, or time. So these are things that we're constantly talking about: the energy, distance, and time. People want to know, how far is the moon? How far is the sun? How much energy do they have? How far does light travel? How fast does it travel? All those types of things. So right away, it's spewing the biggest nonsense that it can spew, and that is Newton's law of universal gravitation. So it's got the square root in it, everybody, but that one's not real. Then we get the kinematic equations, which it should be here for that. So this is uniformly accelerated motion. Now, some of these, they try to use big words. The period of pendulum, or simple harmonic motion. If we take a look at this, search this in Google quick, it's going to tell us that the period of pendulum is a time that it takes for one complete swing. All right, so if you swing a pendulum, it is actually going to invoke a square root in its formula. The period of a mass spring system, like the pendulum, a mass and a spring actually involves a square root in its formula. The root means square speed of gas molecules. So now all of a sudden we're talking about how fast gas molecules move, and now we're talking about things like wind. All right, so the way wind disperses is affected by a formula that has a square root in it. This special relativity is nonsense. The time dilation and length contraction, escape velocity from a gravitational field. It's got a square root in it, but it's not a gravity.
Hold on,
it's
go
not
back
gravity,
up to 6.
right? Yeah.
Go back to 6. So if 6 were real, then me running away from a mountain, as opposed to me running on the desert, we would actually be able to calculate that escape velocity from a gravitational field. There's nothing in our reality where we can actually measure number 7. It's just hilarious. Yeah. I mean, where's your evidence of that?
Yeah.
Like a Stephen Hawking paper?
Now, this one's really important, number 8, the electric field strength from a point charge. So electric field strength, this is all of the electromagnetism, right? So everything that is an electric field has the square root function in it, all right? Energy stored and potential sometimes involves a square root. So wave speed on a string. So this is like a guitar string. It has the square root function in it. So how many it says? Well, we can list 9 to 10 major examples. The total number depends on how many domains, derivations, special cases you're willing to count. Summary, there are many natural laws involving a square root, and at least 9 to 10 prominent ones exist across classical and modern physics. So my response to it was, I was thinking of things considered to be waves, such as electromagnetic waves and sound. are there other things that have inverse square rule? And it says, great clarification, you're focusing on waves. And it says waves with square roots in formulas. So yes, waves often involve square roots in their equations, especially in their speed formulas, due to how restoring forces and medium properties relate. Here are some of the examples. So wave on a string, sound waves in a gas, shallow water waves, speed of light. This is something that in another hangout I'd like to come back to and actually show people that it's the speed of electricity, not the speed of light. Part 2, inverse square laws. The inverse square law occurs whenever a force or effect spreads out spherically from a point source. This is when you drop a puddle in a pond. The intensity falls off. So that fall off has a square root in it. So are there waves that obey the inverse square law? Yes. Wave intensities often obey the inverse square law in 3D space, especially sound, light, or electromagnetic radiation, radio waves, gamma rays, etc. So we've all heard the inverse square law applied to light. It also is in angular resolution. It's also in the distance to the horizon calculation that we use. So square root plus inverse square, do they connect? Yes, they often appear together in derived quantities. Speed of a wave has a square root while its intensity falls off with the inverse square of distance. So yeah, summary, the square roots are involved. So let's talk about square roots for just a second here. And if you go to Wikipedia and you look up what it has to say about square roots, I told you the math's not going to be hard. I want to remind everybody that there are basically just 4 types of mathematical processes that you can do, right? You can add, you can subtract, you can multiply, and you can divide. Right? These are simple processes. You might not be that good at them, but you can understand the concept of adding things, subtracting things, multiplying things together, and dividing them. So the square root is when you're trying to figure out what number times itself equals a certain number. So a simple one for that would be a number like 25, because 5 times 5 equals 25. So 5 is the square root of 25, right? 5 squared equals 25. So these are the simple principles, but it's not as simple as just multiplication and division. So I want to show everybody, this is the stuff that you were afraid of that we're getting down to here. You know, square root of 9 being 3, we get that. That's the easy stuff. But then when you get down into
odd numbers become easy and even numbers become very hard.
Absolutely. And then there's the whole factor of irrational numbers that comes up as well that we'll probably touch on a little bit. But once we get down here, so they're talking about the history. It goes back supposedly to the Babylonians when they started figuring out how to do square roots. Now this right here, this is actually a really helpful and important chart. And so this is the plotting of square roots. And what you can see here is you get a parabolic or a parabola here, and it's not a straight line. And that's important in the way things are measured in reality. So if you have a square root function, there has to be a parabolic arc in the thing that's being witnessed. If you were to witness something that just increasingly got stronger in a very straight line, or got less in a very straight line, a linear line, that would not match something that had a square root in its formula. Formulas are going to have these types of parabolic arcs here. And so if we're using it in a formula that's describing reality, that is what we would have to be witnessing. So then the ways that they actually calculate for a square root, you're starting to see some of the math that they use in order to come up with a square root, because it's not that easy. I want to show everybody this. Where is it now? All right, so this is a linear equation right here. And so there's an absolute difference between a parabolic arc and a linear equation. Here is the parabolic one. I'm trying to find where I have. All right, so here's a question that I asked and give you the AI answer on how much more processor intensive is calculating a square root than your simple arithmetic, like adding, subtracting, multiplying, and dividing. So this is what it has to say about it. Calculating a square root is generally more processor intensive than basic arithmetic operations like addition, subtraction, multiplication, and division. A square root operation typically takes several times longer to execute compared to these simpler operations. So basic arithmetic in a computer, the addition, subtraction, multiplication, and division are relatively straightforward operations that can be performed quickly by a processor's ALU, arithmetic logic unit. They often take a few clock cycles to execute. Square root. Calculating a square root involves more complex algorithms and typically requires a dedicated instruction or a series of instructions. This can result in significant increase in execution time compared to basic arithmetic. So it's 4 to 6 times slower, and modern CPUs often include specialized units for floating point calculations, including square root operations, to improve performance. So it's not just a matter of the computer putting 8 dots up over here, 3 dots up over here, and being able to count all of them and say, hey, you've got 11 dots now. Or putting 5 dots here, 5 dots here, and saying, times each other, and it says 25. When the number is something like 10 and you want to know what times what equals 10, it literally has to guess, and it has to look at tables, and it has to try over and over and over again until it finally gets to a decimal point that you're acceptable with, where it finally rounds off the answer, because the numbers are all irrational, right? And irrational numbers, I just want to point this out again to everybody, that the moment a computer went to calculate one irrational number, if you didn't stop it, that's the last thing the computer would ever do, right? If you go to calculate pi and you want it to calculate pi until that number ends, how long is the computer going to be calculating, right, brother?
Forever. You have to tell it to stop at a certain point. You have to give it a cutoff point of where you want it rounded to, up or down. You have to give it an extra command.
Absolutely. So you start thinking about the quality of these calculations, the intensity of processor needed to do these calculations. And let's go back to what we're seeing here. So I asked it, I'm going to scroll back up, I guess.
Yeah, you get into your punchline here, the point of the whole entire presentation now, right?
Yeah. So we were here. We read that.
We went through this.
This one. Not that important. All right, it says, but what if we are in a simulation? This should be virtual reality. It says, arguments for the universe is governed by mathematical laws like a code base. Quantum mechanics, we know, is a joke. Limits like the speed of light resemble system constraints. And then it says it's arguments against no empirical evidence. That's what we're going through tonight. We're going to be showing the empirical evidence. And so it's trying to write off the idea that it's just an accident that square roots are involved in formulas and how reality works. So it's saying that the fact that the inverse square law exists in nature is not proof that we're in a virtual reality. But then I come back with, what is the process necessary for calculating a square root? And is there any proof of atoms, the said source of materiality, being able to do that type of computation necessary? So what is the process? There's the Babylonian method. It converges quickly to S, but it involves division, addition, and a loop. You have to keep doing this over and over again. Recalculating. So the digit by digit method, long division, this is a manual trial and error. You try over and over and over until you get to your square root. Modern computers, we're learning they can do it, but they're just doing it quickly, where it's trying over and over and over. It's using charts and that parabola that we were looking at. So conclusion, square roots are computationally complex. They require recursive or iterative logic. Can atoms compute a square root? Atoms don't calculate square roots. They obey physical laws. Well, there is absolutely no proof of atoms existing. And the atoms wouldn't be able to do these types of calculations. So summary, and I come back with, what is more likely, that the laws of nature follow the mathematical rules by pure chance, or that the laws of nature follow mathematical rules because Earth was designed from mathematical rules? And so laws of nature following math by pure chance. This is something that's been talked about in the history quite a bit. So the universe could have been random, chaotic, and lawless, but instead it happens to follow precise, elegant mathematical structures, that being Maxwell's equations, things like that. Maybe we're just lucky to be in a universe that happens to work this way. And strengths avoids invoking intentionality or design. So the people that want to believe that the laws of nature just happened to have like square root formulas in them, they avoid the intentionality or the design, right? That's what they don't want to have happen. The weakness is it doesn't explain why the laws are so elegant and deeply mathematical. The probability that randomness gives us a reality that supports life, order, and mathematical predictability seems very small. Option 2, laws of nature follow math because of design. The universe was constructed or programmed according to mathematical principles, like code in a simulation, or created by a mathematical mind.
So unfortunately, that should say code inside of a virtual reality.
Right.
Because we're in a virtual reality, not in a simulation. Okay. You have choice, you have thought. And in a simulation, everything is just an illusion. That's absolutely not what we have here. We're in like a very advanced metaverse.
So mathematics isn't just a language we use, it's the source code of reality. Earth may be a designed system, and math is the framework it runs on. So it talks about this idea being found in Platonism, intelligent design, virtual reality hypothesis. And the strengths are why the laws are so elegant, consistent, and universal. Predicts that mathematics will continue to reveal hidden structure. and consistent with modern physics finding more abstract math like symmetry groups, topology behind forces and particles. The weakness raises the question, who or what designed it? It should be the first thing everybody wants to know, and can be seen as unfalsifiable unless the design leaves testable traces. That's what Ron's going to be talking about in just a little bit. And some consider it an unnecessary assumption. What do the physicists think? And so based on logic and probability, the naturalist, atheist, they want to believe in chance or a multiverse. The theist, designed by a creator. The virtual reality theorist, programmed reality. Mathematical platonist, reality is inherently mathematical. So final thought, the universe behaving according to square roots, inverse squares, and elegant equations is not inevitable but extraordinary. Whether you see that as evidence of design, a virtual reality, or just a beautiful accident depends on how you interpret the deepest layers of reality. And yeah, I am very confident that in order for any sort of square root to be in a formula, like we talk about the distance to the horizon, it's the square root of the height of an observer times 1.22459, and that gives you the distance to the horizon in miles. Light, we know that light only travels the inverse square rule. Angular resolution, the inverse square law determines angular resolution, all these types of things. And they're very computational, like very computational. You can't do it on your own without some pretty good math skills and some time. And computers can do it because they have all these lookup tables and algorithms, and they can do it really quickly, right?
Well, you're basically left with the basic understanding that if everything in creation follows mathematical rules, square laws, and everything that would only be created out of creation, that there's no way that it happened by chance. Every time you find a inverse square law or a rule, a mathematical rule that is exactly the way that it's measured, it's more evidence that that was created. It's not pure random chaos. If some days were 26 hours long, some days were 20 hours long. If things were more randomized, it would be more of a likely chance that we were living in a non-created reality. But the fact that everything in our reality is mathematically measurable, calculated, and that we can all verify these things proves without a shadow of a doubt, and we'll get into some shadow evidence, that we are in a created reality. And whether you want to use the words that we use or you want to use the words that you choose to use, we are still talking about the exact same evidence, whether it's Red's Rhetoric or Jaron Campanella or MC Toon. At the end of the day, we're all going to have to come to the same conclusion that the fine-tuning of this reality is far too special and created,
Precise.
programmed, precisely programmed. If there was more of a chaotic experience or environment that we were in, then we wouldn't be able to have these types of computations.
Absolutely. Well, should we take a
let's go for a song break.
Come back and get into your stuff?
Sure, let's do it. And thank you everyone for tuning in.
And we are back.
Yeah.
And
Thanks
we
for
have
everyone.
got your screen share up.
Thanks again for everyone that's tuned in. Again, the mathematics and stuff like that is complicated, but it can be taken, one addition at a time, and you can learn. Anyone can actually learn how to do any types of mathematics that you actually want to. It just takes the work. So what I'd like to do is talk a little bit more about the physical evidence. So let's talk about sound. So sound also follows the inverse square law, just like light, right? Everything can only be heard or seen for so far, right? But what we don't talk about is how everything actually interacts with one another. So what you're going to see here is a man is going to start playing a flute, and you're going to actually see the wind and the trees obey him. Now, he's not Christ, okay? He's not. We all have the same powers. Christ came here and showed us. He showed us the powers and the way that we can use these things inside of a virtual reality. And again, miracles actually are indicative of a virtual reality. It's inexplicable. You would only find in a virtual reality that miracles could take place. If you were in a physical atomistic Big Bang cosmology that everything just evolved out of chaos, you would never have a miracle. And I'm one. I'm a miracle myself that I'm just here talking to you. So let's start off. Let's take a look at what happens when he starts playing the flute. Let me know, Jason, if you can't hear it or if anything needs to be adjusted.
Sounds good. I can't hear it.
No?
Second.
Want to put the thumbnail on?
Try it. Now I can hear it.
Okay, let's start again. Watching the watch the trees, he's saying. See how they're all moving here? See the movement? Watch. They all stopped. Amazing. Want to see it again? Let's go back to the beginning again, and we'll show it one more time zoomed in. Watch the movement of the trees. See them all moving. Everything's moving. Boom. It's amazing. So this is only possible if we're in a virtual reality, and these trees are also sentient in their own way, just like everything else has its own life force. Okay, this is what we're in. Let's move on now. Let's check this out. Okay, here we have a clear horizon. We've got a cloud deck. We're up in a plane. These more and more of this evidence comes out every single day. So here we go. We're flying along. Here we go. The sun is literally rising up from underneath these clouds. Now, if you're on the ground, right, you literally see the sun also rise up out of the ground.
the exact same way, with a horizon beyond the sun. This is something we can all witness. Matt Long had an excellent video of this while traveling from Dallas to Toronto. Go figure. This is a sunset. Sorry. But it's setting into the clouds. Look, the horizon's over here, everybody. Come on.
You can maybe bring the volume down on the
It's a little
video
loud.
just a little bit.
Yeah, you hear the sound of the turboprop engines just cruising along.
That is some of the best sun setting into the cloud deck before the horizon I've ever seen. That is just
Pretty clear, right?
very clear.
Zoom in. Let's get everybody to see it. Come on, open your eyes, everybody. Wake up. I know it's late. 9/11 Central Standard Time. Friday, May 30th. Okay, the horizon is here. This is not possible in a physical heliocentric Big Bang cosmology, nor does it work on the AE mappa model with the sun circling above your head. This only works in a supernatural biblical virtual reality. SBVR, for short. Say goodbye. Goodbye, Mr. Sun. Sleep well. See you rise up on the other side of the horizon in the morning.
That is really...
Lost it. There it goes. Gone. Where did it go, everybody? Where did the sun go? Look, it continues. Get that sound off. You can
It's
listen to the
underneath
crickets.
those clouds now.
Where did it go?
It's going down into the ground.
Mm-hmm. It certainly didn't set beyond the horizon. So if we were on a sphere Earth, the sun would be over here. Where my cursor is, it would go back behind the clouds here.
93 million miles away.
Due to the fact that the sun is actually fixed, located from a distance from each observer, depending on your altitude, this is the type of evidence that we witness. I don't need to use big words. Here we've seen other people trying to talk about the rainbow. Okay, I know it's been occulted and taken over, blah, blah, blah. The rainbow used to actually be upside down, right? Like a bow with an arrow pointing at Earth. But what we have here is evidence of how light or the objects inside the virtual reality are fixed at a distance away from us. We can't get to them. You can't get to the sun. You can't get to the moon. You can't get to the rainbow. But from a different observer's position, it can appear that you can get someone to go to it, depending on your fixed location. Watch.
Stop! Fucking stop!
Pardon the language. I know it's Friday night.
No, fucking there it is.
F it
dude.
Fridays.
I've got it.
He's got it.
Nobody's ever gone to the bottom of the fucking rainbow. You can't catch a rainbow.
He's got it.
He's gonna
Got
catch
it.
it, dude.
He's going for it. There it is.
Are you fucking kidding? He's about to run through a rainbow.
So what would happen if the photographer started to walk towards the rainbow is the rainbow would actually continue to move away from the observer running.
To the
Yeah,
left,
the guy running
to the
towards
left.
it, he can't see where it is.
No, the people are.
These guys have
so
to steer him.
For him, it's way beyond. It's continuing to move away.
To the left.
So he got it's basically right there. Okay. So what I want everyone to continue to understand is that the rainbow proves that you're in a virtual reality. It's not just a beautiful message that the earth would never be destroyed by water again. We know that it's going to be absolutely burned, destroyed by fire, but it's also a virtual reality proof, right? So the way that the light works, it's fixed to us and it's fixed to the sun. So to see a rainbow, all you have to do is find the sun, right? And then look away from the position that the sun is pointing. So you can't look at a sun and see the rainbow. You'll always be looking away from the sun. And what a rainbow is, right, is basically it shows the sun's anti-position in the sky. It's like a target or a tabernacle that hath been created for us to locate where the sun is. It's just always behind it.
Are you fucking?
And the higher you go in the air, so we usually see a bow, right, Jay? We'll see like a half of a rainbow. But if you actually rise up in altitude, you'll end up seeing a complete circle.
Yep.
Right. And again, this is something that was programmed. It's literally like, we could go so deep. Just make sure you're subscribed. Make sure you hit the bell notifications. Make sure you always continue to follow this YouTube channel here, Awake Souls, because we're just starting to scratch the surface on this. So it's a coded sign, right, that the creator literally added. It didn't need to be added to the sun. Okay. It was added so that we could understand that it was a coded feature added, so that we could understand that we were in a coded reality that was programmed.
And we have absolutely debunked the idea that it has anything to do with a dome.
Yeah.
Right? Because we've seen rainbows underneath clouds.
Yes.
In all those types of scenarios that absolutely prove
No dome.
that it is not a reflection off of a dome.
No, because if you rise in altitude, you see a circle, right? The dome doesn't circle all around a sphere. So let's keep going here. Now we're going to talk about sound waves, again, with the way that they propagate. This is the way that the square root inverse square law works with sound. Okay, this is really cool. You probably want to try this. If you could get a waterproof, I would definitely do it. See how you can calculate and measure the distance between the different ripples and how they interact with everything else in the pond.
That's called a wavelength.
A wavelength, right? If we lived in a random chaotic reality, you wouldn't have these features that you could actually go out and measure and test. And then with different harmonics and frequencies, you can get different wavelengths. I think that's really, really cool. A couple more. We're not going to have too late of a podcast, but here we're going to talk about some more absolute bangers of evidence of the reality that you're in. So you'll hear people mock and laugh. Oh, these stupid virtual reality guys, they actually think that clouds are behind the sun and the moon, right? And they'll mock us and they'll laugh at us, and we'll go, well, yeah, we'll go, well, what's going on here? Why is it that why is it that when these contrails, chemtrails go over the sun, right? Why is it that the shadow goes up
onto the clouds above?
So the same rule about the rainbow, right? So the shadow will also tell you. So when you want to find a rainbow, you have to look the direction of the shadow, right? The shadow shows you the other position. So the sun is always on the other side of
anti-position.
Anti-positional. If you have a shadow behind a con or chemtrail, you know the sun must be under that shadow, right? Most of us measure shadows on the ground, right? Because the sun's in the sky. Well, this shadow is above the sun in the sky,
proving the sun is below that trail.
Listen, this isn't up for debate. Okay, this is not something. Hey, let's get into a debate with MC Toon or Mick West or what's his name? Yeah, the Metabunk. It's not a debate. The debate is over. It's an evidence. This is an observation that we can actually make. Anyone can make this if you have the right con or chemtrails. And again, these are created, right, when engines compress air, right? I don't know if anybody tuning in here ever used to like put your finger over your mouth and then blow really hard and then slowly open your mouth. And what would happen is like a cloud of smoke would come out, right? So when we compress oxygen and hydrogen and all the other particles or whatever it is that makes the air that we breathe, when you compress it, it actually leaves clouds. That's what it does here. Now, a lot of people want to think it's chemicals and they're being poisoned. And unfortunately, there's no evidence for that. The only thing it is witchcraft to try to poison your mind. Now, we've got to do a deeper dive. Maybe we'll do a chemtrails or demonic 2.0 if we get the time. But what I want everyone to see is that these shadows are clearly above. They're above the chemtrail, okay? There's no way in a heliocentric model, the sun that would be 90 2 million miles away, that this shadow is 92 million miles away behind the chemtrail that's 93 million miles away. It doesn't work.
That doesn't work. No.
No, the sun literally has to be local. The chemtrail has to be from this vantage point, from this viewer, above the sun, which is casting the shadow above the contrail, chemtrail, however you want to call it. It's obvious. I mean, does everybody in the chat see? Is there anyone that doesn't understand what we're showing here?
Yeah, maybe in the chat we have Neo that says they had wished to stop and have a photo taken of when they drove through a rainbow. Well,
yeah,
Ron showed the example. You would need to have somebody else from a farther position photographing you drive through the rainbow. You could never do it yourself. That wouldn't be possible.
You can't catch a rainbow. That's why there is the idiom that you can never get to the pot of gold. You can't get to it because we're in a virtual reality and that rainbow is fixed at a distance away from you. You can't move closer to it. So is the sun, so is the moon. But when the sun is fixed to your distance and a chem or contrail goes above the sun from that vantage point, it casts shadows upwards. I don't know how people, if you can't see this, okay, this sun has to be below these chemtrails for the shadow to be casting above them. And not only that, this is witnessed and observed by everyone everywhere. Here's some footage that I took just like a few weeks ago. And you got the new moon here, or almost new moon, just a few days past. Look at this shadow. There's the moon. Look at how straight line. How is there a straight line shadow up in the sky like that? How? So the sun is below.
From a sun that's 93 million miles away.
So the sun is just about to set into the ground. It's below. And the light rays are shooting upwards like this. And what it's doing is it's casting the shadow off these clouds. Look at the line that it's created. Look at this.
Set to the west.
Setting.
It's doing the craziest shadow I've ever seen.
And I've got other footage too that like I said, we're just scratching the surface tonight. What you can actually witness yourself. Look at that.
Glitch in the Matrix, I guess.
Glitch in the virtual reality. These are the types of things that were left here for us to explore and investigate and come to our own conclusions. Are you going to be fooled? Do you think that this sun is 92 million miles away? And that somehow it's just happening to catch this corner of this cloud and create a completely straight shadow? Or is it local? Is that sun like 4 miles away or 3 miles away? And it's shining up on this cloud that's only a mile away from me. I'm creating that straight line shadow. Just look at that. Look at that shadow. So it's up to you on the other side of the screen. We'll go back to the rainbow again if someone wants to see that.
Yeah, we have a comment from R. If the Earth is a virtual reality, it is, how can we be certain that the laws of physics that govern this world apply to the virtual world? I mean, if they hide the virtual world, maybe the laws also? So the laws of nature are the things that are measurable. That is the distance to the horizon. That is the laws of angular resolution. That is light. You can see that, try using your cell phone light, see how far a person can see you with that cell phone light. You're going to find that that light does not travel forever. You also notice that if you go into a stadium, if everybody turns on their lights to their cameras, to their phones, they don't light up the whole stadium. All right. So these are the laws of physics that are witnessable, that are tangible. We know that they're taking place, and they do govern the world that we exist in. And they are proof when they use things like square roots that these are the laws within a virtual reality, because that type of mathematical equation isn't going to be calculated anywhere else.
Absolutely not. And so if you were able to get to the end of the rainbow, he would have been able to easily run to it. But what he can see is the rainbow continue to move away from him and he can't see it anymore. Right. And so again, we can continue to show you all these different things. Like this shadow is literally above the contrail. Okay? It's not below it. There's a shadow here. There's a chemtrail here, a chemtrail here. Here's the sun below them. And you got another layer of cloud deck above that. And you can clearly see that the sun is casting shadows upwards. It's just evident. It's not up for debate. I'm sorry. If people don't want to see, here's a higher chemtrail. It doesn't have a shadow up. See that? It's beyond the distance that the sun would be. It's only locally happening here, right? I don't understand how people can't see this. It's like you either take the blue or red pill or whatever. If you can't see that the sun is right here and that these are actually above it, the shadow tells you where the sun is, right?
Yeah, there's people that still can't see it. We've got somebody in the chat, Dave Schmeling, that says that that's just a reflection off a shadow. That's a shadow being cast upwards onto higher clouds. But yeah, if a person can't see that, they can't see it.
Yeah. Well, and it's sad. So this is that last bit of information that I want to bring up. Maybe we'll get back into steam powered engines again sometime. It's sad, Jason, that they took away steam, right? There's so much power.
Oh, you can do so much with steam. It's insane.
They hid some of the best technology that we had. This is a jet powered steam bike. Check this out. Just to bring steam back for a little. Hey, what's going on? 3, 2, 1. Gone. Oh yeah, that's gone. I love drag racing. Just for anybody else that's tuning in, I've been drag racing my whole life. I remember when I went there when I was a little kid, I cried. It scared me, the noise and the smell. And now I actually get tears in my eyes from it on how much I love the sound and the smell. But again, let's watch this again. So this is a steam-powered jet bike. I mean, unfortunately, they got all these ridiculous wastes of money. Windmills are just the stupidest thing you could ever imagine. They cost so much money, and then they have to get buried in the ground. But watch this jet bike again. 2, 1. It's gone. It's literally gone. And she definitely got to experience it. So it's an amazing thing. We'll have to do a podcast maybe if there's some interest.
Yeah, some more steam. I just want to remind everybody that likes steam understands that steam gives you like a 300x boost, because when water boils and it turns to steam, the volume goes up by 300 times. So that right there is an incredible power boost. But keep this in mind, all you have to do is lower the pressure on the water, and you don't have to go with as high of a boiling point. So a lot of people, when they hear that, oh yeah, we've got steam powered generators, right? Coal powered, natural gas powered steam generators. The thing is most people are thinking, yeah, you got to keep that flame burning hundreds of degrees in order to get the water to boil at 212 degrees, right? Well, all you have to do is lower the pressure on the system, and then the boiling point goes down, and you don't need 212 degrees in order to make the water boil. In fact, if you get the pressure low enough, you can boil water at freezing if you want. Yeah. So there's a lot of tricks to be had in the physics of using steam. I wonder how that bike is, how it's producing its steam.
Yeah, we can look into it more further into the future. I mean, if your face isn't like this after the information that you are getting here on the Awake Souls YouTube channel, I don't know what's wrong with you. I'm sure, math is math. It's a little tough. But I mean, when we tie it all together, when we show you the different evidences of tree interacting with sound, right? With the sun setting way in front of the horizon. Okay, everybody, come on now. Stay with us here. We're just showing you what's going on. This guy can't get to the rainbow. He doesn't see it because it's continuing to move away from him. Show you how the ripples work with the inverse square law. Shadows above chemtrails and the steam power. Okay, we live in a beautiful water reality where we can take water and we can do so much with it. And we're not using it enough. So thanks for everyone for tuning in tonight. Jason, I don't know if you got some final words. There'll be a Rise and Grind podcast, as always, on Sunday on Rumble. The link in the description box to the Limitless channel. We'll be doing some headlines, some new music, some memes. You won't want to miss that. That's going to be a good time on Sunday. And we'll probably do a Sunday night stream too. There's so much to cover with the scriptures and everything that's going on. I'm just excited to be here. Thank you everyone for tuning in.
Where's the only place people are going to get this content, brother?
Only on the Yahawashai News Networks.
Calm the storm, just keep paddling. Hold the fort with red line, so you can go and talk the talk 200 miles apart. And I'll